don't want to have to do this again. If you have an even indexed root, one thing you don't want to do is that you don't want to, you cannot take the square root or the fourth root or the sixth root, any even indexed root of a negative number. So that's why they say that if you're looking at a radical and it has, remember the radicand, that the radicand must be greater than or equal to 0. Because you can take the square root of 0. Square root of 0 is 0. What times itself gives you 0? Well, 0. Okay. So for example, if you take a look at x minus, the square root of x minus 3, the radicand is what's under the radical, is x minus 3. X minus 3 has to be greater than or equal to 0. So if I look, x is greater than 3, that's your domain. But it's only true for even indexed roots, because if you can take the cube root of -8, that's -2. So you can have a negative number if the index is odd. Index even. Even index, this says the radicand must be greater than or equal to 0. X plus 2 must be greater than or equal to 0. Or x must be greater than or equal to -2. And I'm just going to put D for domain. That's the domain. Cube root, what do you notice? Odd. And if you see an odd index, what's the domain automatically? All real numbers. And if I don't know if I've used this before in this class, I know you use it in college algebra all the time. That means all real numbers, so I don't have to write the word all real numbers. Even. So this says that 8 minus 2x must be greater than or equal to 0. Or that minus 2x must be greater than or equal to minus 8. Subtract 8 from both sides. If I divide by 2, -2, what has to happen? The signs change so that x is less than or equal to 4. That's your domain. Okay, you try the next one. What's the answer to the first one? Even index. What's under the radical has to be positive. So x minus 12 has to be positive. 3x has to be greater than or equal to 12. Or x must be greater than or equal to 4. What's the answer to the second one? Because index is odd, all real numbers.